I'm just going to go to the really high level basic GIS 101 to start off with. Basically, we're just going to talk about GIS and really talk about spatial data here. Start off. Basically, spatial data is just location in nature somewhere. So where your house is, where you're standing, where one of your assets is out there, or a bus is driving around, doesn't matter. That's really what spatial data is. It's points, lines, polygons. So don't get this confused with GIS. This is really the foundation layer of GIS, but you have to have this part of it. And with that, you see some nice representations of how you can, use spatial data. Something is within something else. How does something relate? Something touches something. So in this case with the LiDAR stuff, where does the water touch? Where does it get above a certain elevation and then creates havoc? So everyone kind of understand all that? We good? All right. This thing is just spatial data right here. Just stars, lines, and boxes. Means nothing to you, does it? Or does it mean something to somebody? Yeah, it's just locations on the earth of things. So that's a nice slide, isn't it? So really, what is GIS then? It's just basically your computer software systems, hardware, data, people especially, to analyze information that you get. So kind of like what we're talking about here. You want to analyze information, especially spatially. So, and this bullet here, it's really about your business data. Location is just a piece of business data. That's all it is. It's no different than a text field or a number field in a system. It's just a piece of business data. So we can't look at it as something that's foreign or different. It's just part of business data. And almost everything we do here has some type of spatial object or component to it, a location. And a growing number of systems, are storing this information and making it available. How is it used? So on the EOC side of things, really think about how things are going to get used. So there's some analysis things in here. Where do you put down materials in the winter, and how does that affect your paint condition out there? These are things that have relationships with each other. So again, oh, it's that box again. So now the box, we've actually taken the spatial data now and merged it with business data, other business data. And so now we see that, we know that star 1, wherever star 1 is a type of soil in that borrow pit A. And you can kind of see how now we have a deer kill with number 3. We know that number 2 is a sign. We know that 5 is soil that came from this location that was used. So let's say we're having a road that's having some trouble 10 years down the road. We may want to know where that borrow pit came from. Now we want to know where else was that dirt used or the aggregate used in different locations. So now we've just taken business data and spatial data, merged it together, and it's given us some intelligent information. That's all I do. So you understand that, and you can do my job. So that's really it. So that's it. So, all right. So with that, I'm just going to touch on a few foundation layers that we're driving for that help make data available to people, especially spatially at the department. Geospatial management, that's kind of the stuff that I do and my team works on. Plus we also have office staff that help drive some of that management and so on. In a transportation system, you need a linear referencing system. And I'll touch base on that really quick. You need an enterprise way to store your locations of things. So we have a lot of stuff stored in databases here, so we want to leverage those databases by storing another attribute called like a geometry with that business data. We don't need to store it separately. Let's store it with those business systems. Web services, which are key. Back in 2000, I think it was 8 or 9, here in Iowa, we formed a thing. We're trying to develop something called the Iowa Geospatial Infrastructure, IGI, which allows all different levels of government and entities within the state to communicate geospatially through web services. So that was really the crux of starting a web services here at Iowa DOT. Different software that you buy, people use Esri products, Intergraph products, QuickTrain Modeler for your LiDAR. Is that what you were using? QuickTrain Modeler. So all that's different types of software that works with spatial data, if you want to call it. Remote sensing, that's LiDAR data, aerial photography, geospatial professionals in the office, very important. So we have to have those. Staff and governance and standards. So basically all the you hear LRS out there, linear referencing system, what is it? And basically there's a common centerline network for all of our roads in the state. Not just DOT owned, but locals and so on. And basically it allows you to locate things along the road using different linear referencing methods. So who uses mileposts out there to locate something? No one? A few people, yeah. So a lot of people use that. That's a method to locate along the road. A coordinate, so I got a GPS unit, I know I'm right here. That's another way. Little description is another way. I'm 400 feet north of the intersection of Main and Maple on Main. So there's no business data in the linear referencing system here. It's a standalone system that allows you to push in a location and get something back out. So for instance, in this scenario here, so this is a scenario I gave to DPS a few years ago about how they can leverage our linear referencing system for incidents that come in on phone calls to their NOC. So basically, their CAD system I should say. So if a call comes in here, it could pass that point to our linear referencing system. And as you see at the top here, that point on the Iowa, this is 69, US 69 Des Moines, that point for the DOT is known as reference post 86.4 on US 69. That's how us in Iowa, DOT, would be able to find that location if we had to go out in the field. But for the locals, it's also known as, could be known as those. It says 300 feet north of the intersection of Cleveland Avenue, US 69. That's using our route name on here, along with so far north of Cleveland Avenue. But it can also go against the local naming system. That road's also known as 2nd Avenue. So now multiple jurisdictions can know the location of that. So something that comes off DOT network, here, that call comes in, there's no post location, but we still get a location for the locals. And if we had addressing added to our linear referencing system, then you could also get an address back. So that's all LRS does. So if you think about if you have a deer kill or something else out there, basically you're going to pass that location to the LRS. It's going to give you basically a geometry back, or it could give you some other type of coordinate or so on. So, and you store that in your database. Good, good, all right. And this is another power of having an LRS with linear features, is you can do linear overlay. So basically, if these are all separate databases out there, so this one stores speed limit, ADT, pavement type, IRI, what the linear reference system can do is combine this data together and get you an answer. So if you have a question, I need to see where speed is greater than 45 miles an hour, ADT is so on, pavement's this, IRI is that. Where does that exist on our system? Because we want to investigate that because of an issue. The LRS then would take those things, match them together, called a linear overlay, we return these two chunks of road in this scenario back to you. And you know that's where it meets those criteria. So that's it. That's all there is with that. So, all right. So what I did was I emailed over as we're walking through this, and I find this type of stuff really interesting. So I emailed one of my guys and said, okay, make me what you would anticipate would be a transportation, emergency transportation map. This is something that this is instantly mobile. So we could have these things available so anyone in the field on their phone, I might bring up my iPad right now and show you the same thing. They could see things going on out here. So I had them say, okay, what do you think is important for an incident response map? So what we're seeing here is mashing up a bunch of information. So here's what we're mashing up. Now this data is available to not just this map, but any other types of maps you want. And the data can also be available to any of our partners, just as easy as my guy put this together this morning. So if you're dealing with a county, they can pull the same data you're seeing, drop it in. So in this situation, looks like we're showing Northwest Iowa. These are our locations of our, I guess, what do you call these plow vehicles, Bob, in the summer? What do you call these things?
They're still plows.
They're still plows. So we're showing locations of some of our vehicles out here, all right? We're also showing real-time traffic information on there, so we can see how fast the traffic's moving. Let me look what else we have going on here. We have all the different hazards and warnings going on. There's also stream gauges on here. So these are real-time stream gauges. National Weather Service or whoever does the stream gauges, not USGS, they provide a web service you can just drop the stuff on, and they color code it based on where the gauge is at. So now people in the field could just drop that on your map and roll from there. things available for the people in the field. Now, again, this was put together in the last hour. So this didn't exist an hour ago. All right, so here's what you're seeing, how you can just take data, mash it together really quick. Now we're suffering from, on the left side, we're suffering from a technical thing. I call that in our group layeria. So we have a lot of layers going on in here because we haven't smoothed it to make it, so it's people can interface with it. As you see, we're zooming in here to Ames. What we're getting is we're seeing the rail crossings, bridges right there. We also have DOT buildings. But as you see, there's where our trucks are parked. But so in emergency response, you could have access to a lot of different information. Like we have bridges right here. Let's see if he enabled the clicking of a bridge here. No, we can just turn that on. Rail crossings that we store here. Real-time traffic. I also had him add just a couple minutes ago before.
Traffic cameras are on there.
Oh yeah, we got the traffic cameras on here. So if we like with the plows have those dash cams in them. If you get to an incident, you could park one of those plow vehicles there. It could sit there and just broadcast a picture back to us every so often, and those pictures then would come up on this map, and you can have, I guess, a poor man's camera situated there where you could see what's going on for situation. There's also stuff in here like, let me see here, nuclear power plants, gauges, all that good stuff. So as you see there, you can start mashing this stuff together. Oh, and here's Cars 511, Sinclair. So about a year ago, we started a project to start harvesting the cars data in real time and then storing it off historically so we can deal with when things close and stuff. So what we're doing is this is real-time cars information. So you can take the cars information, also overlay in other maps. So, and there's also on here the current detours that are going on at the DOT. See that little line right over there, right below where District 6, Power Chic? That's one of the detours going on. And that comes out of the stuff that Andrea was working with me on for the project stuff. So we're just, the major construction project. So we're just reusing that data, dropped it on here. Now it's available to the people. So basically what I've done, what not I've done, but the person I asked to do this morning, they've taken these things called these geospatial web services that we have. Basically, they're reading DOT data from databases that we already have in place, and it's turning into what we call a map service. And those map services can then be dropped right on these maps. So let's say I wanted to go and drop a layer on here. All right, so this is what we call a REST library. So I'm going to take that traffic operations map that I was showing you, and let's say there was some other data that needed to be added to it. So our operations center here says, hey, we're really in need of, where's our airport people at? Can I pick on them? All right, let's pick on them. All right, so let's say we need to add Part 77 surfaces for airports on our operations map for some reason, because we're going to be dealing with planes coming in or something. So back in the Ops Center, they would take the map that the field people are using on their phone. They would come here and say, yep, we have Part 77 surfaces right there. Let's take this URL, select all. Just going to do a copy of that URL. I'm going to go back to my ETO map. I'm going to say add layer from web. Now you're going to see that my job really is not very, add layer. And let's see what happens here. There's aviation Part 77 surfaces added to the map. Save the map, done. Everyone using this map in the field or anywhere now has that information on there. And so also with this map, the user can also change to different types of base maps underneath. We can do that. We also have a set of aerophotography that Tom Sampson manages and maintains that makes available out here. That takes the best and the most current imagery and makes it available to us. So we can do all that. So, and during the 2011 floods, we were getting some flights. I think someone was doing some flights of the area. And so what we're doing was taking that and making mosaics and turning it out there so they're fast and cached for use. So it was a state patrol. So, yep. So it's a pretty valuable tool, and I don't think we're leveraging it quite enough in the operations side of things, especially the emergency side of things. So good for like Andrea's group there to be able to put this stuff out. The nice thing is, if you're dealing with a county with you, their GIS person, the county, can pull our data in. So if we have road closures or other data, they can drop it on their stuff, inform their citizens. At the same time, they can make services for us. Don't you want to know where the local roads are closed? How big is that a problem in a flooding situation when the locals close their roads? Do you know it? Probably not. I know in 2011 we didn't. And so, but, all right. I don't want to hog all the time. Is there any questions about this? I know I'm meeting with operations folks on Monday to kind of talk about this more in detail. I'm more than happy to come and talk to you at your office about this to kind of show you how you can leverage this and have you use this technology. So, anything? Questions? Bueller? Okay, thank you.